Hello friends, today we are going to see the trick to get the roots of a complex variable. So let's jump directly to the sum and then only we will see the trick. Okay, so first sum is of in09. One of the roots of the equation x cube equals to j, where j is a positive square root of -1 is, and we are having this option. So basically we have to get the roots of this equation. Okay, and here this j is I, which is basically root of -1. This is what this statement is saying. Okay, so first take a look how I solve this sum using the trick. So the answer is root 3 by 2 plus j 1 by 2. So from the option, this C is the correct answer. Let me just give you a quick review on the traditional way, then I will show you the detailed explanation of this trick. So here you have the equation x cube equals to j. If you want to do this sum by the traditional way, what you will do, you will take this j on this side. So you will get x cube minus j equals to 0. Then you will arrange this statement into a cube minus b cube form. So for that, what you have to change this j to some other element. So for that, what you will do, you will replace j as x cube minus of minus j cube, because here minus j cube will be -1, this minus of 1 ka cube will be -1, and this j ka cube will be minus j. So you will get j here. So you can replace this j to minus j. Now you have a cube minus b cube form. So what you will do, you will use the formula of a cube minus b cube, that is a minus b, a square plus ab plus b square. Okay, and from this equation you will find the roots. And note this thing, finding the roots is not easy because you have a imaginary term also here. So you can see, if you try to do this sum with the traditional way, you have to spend at least of 1 minute 30 seconds. Okay, but with the trick you can solve this sum into 5 to 10 seconds. So let's see the trick here. So the trick is, you have to replace this j into exponential form. Okay, so you have to replace j to e raised to j theta form, since we want j, right? And for j we can write this as cos of pi by 2 plus j sin pi by 2, right? Because cos pi by 2 will be 0 and sin pi by 2 will be 1. So ultimately we will get j here, and we can write this equation as e raised to j pi by 2. So that's what I have written here. So I have converted this j into exponential form. Now I want the roots of x. So for that I have taken the cube root here. So x cube into cube root will be x, and here I got x e raised to j pi by 2 into 1 by 3. Okay, so basically this power will become e raised to j pi by 6. Now I have just expanded into cos theta plus j sin theta form. So I got cos pi by 6 plus j sin pi by 6. So cos pi by 6 will be root 3 by 2, and sin pi by 6 will be I by 2. So here you can see from the trick you can solve this type of question in just 10 seconds. But with the traditional way you have to spend at least 1 minute. Okay, now let us say this sum. This is of IN07, as well as this sum was came in ECEE IN 2012. Okay, the sum is, let j equals to root of -1. Basically j is I here. Then one value of j raised to j is. Okay, so by the trick you have to replace this j into exponential form. So what you will do, we know this j can be written as e raised to j pi by 2. That's what I have elaborated in first sum. Okay, so now this j raised to j will be e raised to j pi by 2 raised to j. So you can write it as e raised to j into j will be -1. So you can replace it as e raised to -5. So you can see the correct option will be this t. But if you try to do this sum by the traditional way, you have to spend at least 1 minute. Why? Because you will assume y equals to j raised to j form. Then you will take log. So basically log of y equals to j log j. Now you will use log of a plus jb formula, that will be log of under root of a square plus b square plus j tan inverse of b by a. Then by simplifying it, you will get the answer this t. So you can see this traditional way is very much lengthy and you have to spend more minutes here, but with the trick you can solve this type of sum in just 5 to 10 seconds. Okay, now let us see this sum. This is of EE13, square roots of -I, where I is under root of -1 r. So basically here we have to get the square roots of this -I. Okay, so again we will do the same thing. We will replace I into exponential form. So for that, what we will do, for -I we can replace this -I into exponential form, that will be e raised to minus of j pi by 2, right? If you elaborate it, you will get cos of minus pi by 2 plus j sin of minus pi by 2. So this will be 0 and you will get minus j here. Okay, so this is what this exponential term is saying. Okay, but now we have to get the square roots of this minus I. Okay, so for that we have to take the square root of this term. Basically e raised to minus j pi by 2, if we take square root we will get raised to 1 by 2. Okay, so basically I have written the square root into this x raised to 1 by 2 form. Okay, so in power I have written. Okay, so if we simplify it we will get e raised to minus j pi by 4. Okay, if we elaborate into a cos theta plus j sin theta form, we will get cos of minus pi by 4 plus j sin of minus pi by 4. So from the option you can see this B option, cos of minus pi by 4 plus j sin of minus pi by 4 will be the correct answer, since none of the option has this roots. Okay, but here we have to get the two roots. With this one root only you can get your answer, but let us find the another root also. For another root, what we will do is, we know this cos theta sin theta are periodic signal with the period of 2 pi. So this minus pi by 2 can be written as 2 pi minus pi by 2. Just I have added to 2 pi here 8. So you can get 4 pi minus pi, so 3 pi by 2. So you can replace this e raised to minus j pi by 2 as e raised to plus j 3 pi by 2. So if you take a square root of this term, you will get e raised to j 3 pi by 2 raised to 1 by 2. So you will get e raised to j 3 pi by 4. So you can replace it as cos theta plus j sin theta form. So you will get cos of 3 pi by 4 plus j sin 3 by 4. So this is your answer. So these are the two roots. Okay, so you can see in this B option you are getting this two roots. Okay, now let us see this sum. This is of in09. If z is equals to x plus jy, where x and y are real, the values of e raised to jz modulus is, so you have to get the value of this mod of e raised to jz. Okay, well, this sum is not of square root, but I have taken just to show you how to solve this type of sum also. So what you will do, you will replace z into x plus jy form. So you will get e raised to j x plus jy form. So if you resolve, you will get e raised to jx minus y. So you can write it as e raised to jx into e raised to minus y into mod. Now with the property of modulus, we can separate this into e raised to jx into e raised to minus y. The modulus of e raised to minus y will be e raised to minus y itself, and the modulus of e raised to jx, basically the modulus of e raised to j theta, will be 1. Why? Because you can replace this e raised to jx as cos x plus j sin x. Okay, now if you take modulus of this e raised to jx, you will get under root of cos square x plus sin square x, and with the trigonometric identity this term is 1, so under root of 1 will be 1 itself. So the solution of this question, e raised to jz, will be e raised to minus y. So the correct option will be this D. So you can see here, if you know the tricks, you can solve this type of sum very easily in just 5 to 10 seconds. But with the traditional way, you have to spend at least 1 minute or more than 1 minute. Okay, so that's it for today. Thank you guys.
हेलो दोस्तों, अगर आपको मेरी वीडियो पसंद आ रही हो तो डू लाइक दिस वीडियो, शेयर विथ योर फ्रेंड्स एंड सब्सक्राइब टू माय चैनल. थैंक यू.